Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Green Tech Today is provided by Cachefly at CACHEFLY.com.
This is Green Tech Today, the Twit Network's Top 25 Green Tech Innovators Series. This episode of Green Tech Today is brought to you by the Eco-Imagination Challenge from GE. GE and its partners are awarding $200 million to ideas that help build the next generation power grid for the 21st century. For more information and to view and comment on ideas, go to ecoimagination.com/challenge. And by Squarespace.com, the fast and easy way to publish a high-quality website or blog. For a free trial and 10% off the lifetime of your new account, go to squarespace.com and use the offer code GTT. Nearly 1/4 of the energy used by commercial buildings in California is for lighting. That number jumps to 37% for households. Considering that 90% of the energy used by incandescent light bulbs is lost as heat, there's got to be a better way to light our public and private lives. That's where the California Lighting and Technology Center comes in. The CLTC was formed to accelerate the development of energy-efficient lighting products and get them to market and saving energy in 3 to 5 years or less. Here at the California Lighting and Technology Center, we're looking at a lot more than just light bulbs. This is the center's director, Michael Siminovitch. Michael, can you tell me what exactly you do here at this California Lighting and Technology Center?
At the Lighting Center here, we're responsible for moving technology from laboratory to marketplace, but development of energy-efficient lighting technology. So we're a broad group oriented towards bringing new technology into the market.
What spurred the development of this organization?
The utilities here in California and the lighting industry here in the United States got together with the Energy Commission and said, let's develop an innovation center that really concentrated on making a difference in terms of lighting energy efficiency. So they created this group really to be very practical and very focused on bringing new technologies into the marketplace.
Do most of the ideas, are they coming from within the organization, the researchers who are a part of it, the designers, the engineers, or is it, or a lot of them coming from outside, from the commercial partners as well?
The center is really established as a collaborative, and I don't really care where the good idea comes from, as long as it's a good idea.
Yeah.
So we rely on our manufacturing partners. We also have a lot of very clever researchers and engineers here. But I'm more interested in the collaboration and getting the idea into the marketplace. We're less concerned about the fundamental or the basic research. We're really interested in getting ideas commercialized and actually saving energy. And this is what really needs to be done in this country. We need to concentrate less on basic science. We need to concentrate more on saving energy today.
I think that's a really great point. In terms of saving energy, office spaces are one example of a place where you have lights on all the time. Here in this demonstration space, what are we looking at? What kind of technologies are you working on and demonstrating here?
This is basically our Office of the Future lighting project, and what we're doing is the Office of the Future we really wanted to happen right now. So we're working with our industry and our utility partners, developing new types of task lights, new low ambient approaches, new spectral distributions where people have a very high level of control over the office environment. So by putting together controls and new types of LED light sources, we can get 40–50% energy savings. And we're commercializing this, we're working with partners and doing demonstrations.
So moving from the office area, you've got a lot more going on here. Is the on-off controls, is there much in the way of motion sensing in this Office of the Future?
Yeah, so all of this Office of the Future here has got a multiplicity of controls. We have controls over the lighting spectrum, and here in the ceiling we're looking at different colors of light to accent mood and behavior and to look at creating comfort within the workstation. So we're working with some new LED technologies. We're also using occupancy and vacancy controls in the ceiling here, and when someone goes away for lunch or they leave at the end of the day for work, the lights will actually reduce and actually go fully off if they're not coming back from lunch. So here we can get 30–40% energy savings, and this sort of office of the future is really office of today.
From indoor to outdoors. So
Yes.
what do we have here by way of outdoor lighting? I see there's a bunch of lights, overhead lights here.
These are all different types of lighting systems that would get used in parking lots or in on street lighting or any kind of area lighting around commercial buildings. And this is what we call the Smart Adaptive Lighting Initiative, and it turns out that parking lot lights and street lighting is an enormous opportunity to save energy. And the concept here is that these lights can be reduced somewhat during the long periods of vacancies. At 2 o'clock in the morning, there's no reason why our parking lots are on at full level. So we're working with the industry and we're working with the state, and we're developing codes and standards that will encourage the use of smart, security-enhanced lighting. So this is our demonstration, and we're working very closely with the industry on this.
What kind of things are you working on to move from outdoor to like hallways? We were talking before we started shooting here, and you mentioned that hallways are one of the largest energy wasters.
Yeah, this is true. We found out through a lot of our monitoring studies that corridors inside schools and commercial buildings are huge opportunities for energy savings. We found out in our data that corridors represent one of the largest single savings in the United States. I can go from a very low level of light very simply to a very high level light. So now the lights are actually increasing to full level. And during periods of vacancy, the lighting systems can be reduced down to a lower level. So this kind of savings, we can typically get 40, 50, even 60% savings in a typical school or institutional building or a commercial office building. And so all of these control systems that we have on the wall here are designed to simulate the kinds of sensor technologies that we would embed inside these fixtures to allow for this kind of adaptive control.
Do you think we require regulation to be able to actually implement these changes in an effective manner?
I think it requires both approaches. All the concepts that I've shown you are cost effective, and so that if you were a school or a commercial office building, it makes a lot of sense economically to put these things in.
Moving from commercial and office applications, there's a lot of consumers are thinking about their homes and what
Absolutely.
they can do in their homes.
And residential lighting is a huge opportunity for lighting energy savings. And the sad reality is that in this country, we're still using incandescent light sources for our predominant light source. We spent many years trying to encourage consumers to use compact fluorescent. But unfortunately, compact fluorescent has some challenges with color and with some amenity functions. It doesn't dim well, and sometimes they don't last as long. So we're very concerned with the development of technology that consumers actually like. And so we found that it has to have really great color, it has to look good, has to work well, and has to last a long time. This is a demonstration of a number of different typical residential technologies, pendant mounts and wall sconces and ceiling fans. And here we're looking at all LED technology. And light-emitting diode technology has the promise of providing very high levels of color, dimmability, and also longevity. These are all color displays. And what we're doing here is we're looking at downlighting. Downlighting is a very popular technique for lighting residential spaces. And we're actually very focused here on color work and trying to train architects and designers and contractors that they really need to look at these kinds of human scale types of problems. Manufacturers are more than capable of producing high quality CFLs, and they want to. And so I think the idea is that we need to put the two together, the need with the production capability. So that's what a lot of this work is oriented towards, is trying to get people to understand more about color and usability.
All right, so we've seen office, we've seen a little bit of outdoor and a little bit of indoor lighting. What about smart lighting? We've a lot of different areas of energy efficiency are in the systems themselves, where
Yes.
the systems do things without you having to worry about it. Is that part of the
I think that this is a big part of our future is going to be in integrating control technologies with our lighting systems. There's a very big push in this country to develop higher efficiency light sources, but we found out that actually the largest portion of our energy savings in this country is going to be from lighting controls, and that is reducing the amount of light when no one's there. And so, or at least, you can turn it off, you can reduce it a little bit. And so we've actually found that about 50 to 75% of the energy savings that we can get in this country is associated with how we use the light, not necessarily with the light source itself. And this is kind of a really good example. This is a parking deck or a parking garage fixture. And parking garages are famed for being on 24/7. You go into a parking garage at 3 in the morning and it's all lit up. Now we need the light for security and safety and et cetera, but what we can do is that in parking lots that are not being used, we can reduce the light a little bit. And so if you see on the face of this fixture, there's a small sensor, and what that sensor is doing is looking out into the parking lot and actually sensing if there's anybody around. And if there's somebody around, the light will be at full level. Now when we go away, this fixture will reduce down by 50%. So it's we looked at this as a standardized approach for the future lighting of America, that all exterior lighting will have some type of adaptive capability to it. It's a big future.
So let's take a final stop in your fabrication facility.
So at the Lighting Technology Center, we fabricate and build prototypes. If we think of an idea, we have a meeting with a manufacturer, in the afternoon we can actually be constructing it. So all of this apparatus here is set up for folks to actually make prototypes, develop reflectors, develop systems with partners. So very quickly we go from lab to idea to prototype, and then we go out and the manufacturer works and commercializes it. So we're very involved with prototyping. Right behind you is actually we have a large apparatus here that we're building, and this is a large test chamber for high performance lamps for street lighting and for parking lots. And so this is actually an experimental chamber that we've built. So we had a large utility and a manufacturer come here, and we're partnering, looking at some of these performance issues. So one day we think of the idea, and in the afternoon we actually build this. So the Lighting Center is very can-do, and it's sort of very much about getting these things put together quickly, taking the partnership and actually producing real results. And so we're a lot less on basic science and much more on actually creating real results that are really going to save energy.
Make it happen.
Make it happen.
That's great. Well, thank you so much for
My
your
pleasure.
time today. This has
My
been
pleasure.
a great tour. We've seen the demonstration facilities, and up next, after we take a short break, we're going to be talking about the engineering and how they build some of this stuff. Stay tuned.
We're partnering with 4 of the biggest venture capital firms in the clean energy space, 3 in the US, 1 in Europe. Again, we think that the combination of GE investment and venture capital investment is going to allow us to increase innovation. It's going to allow us to accelerate new ideas. It puts us shoulder to shoulder with some of the smartest tech investors, and we can use what I would call the industrial clout of GE to bring technologies to this marketplace faster.
GE announced its challenge at a San Francisco event along with its 4 venture capital partners. Emerald Technology Ventures, Foundation Capital, Kleiner Perkins Caulfield & Byers, and Rockport Capital Partners have all joined with GE. Ideas from companies and individuals can be entered through the ecoimagination.com website for the next 10 weeks. So check out ecoimagination.com.
And by Squarespace.com, the fast and easy way to publish a high-quality website or blog. Squarespace.com has an easy-to-use user interface for creating and managing a website or blog. Optimized for both beginners and CSS experts, makes it easy no matter your level of expertise. Hundreds of design templates to choose from, and you can customize any of the designs to fit your needs. And it includes several modules to build your website, a blog module that can import and export your data from WordPress, Blogger, Movable Type, and TypePad. Use Squarespace for all of your website needs. Build it, host it, and update it anytime. For a free trial, go to squarespace.com. Sign up for a free account. No credit card needed. Just try it out. Build your website. Then, if you decide to purchase it, use the offer code GTT and get a 10% discount off the lifetime of your new account. That's squarespace.com and use the offer code GTT. We've seen some of the cool lighting technology solutions here at the California Lighting and Technology Center. What are the engineers working on for our future? This is the Director of Engineering, Keith Graber. What we have here is it's low power distributed DC voltage.
That's correct, yeah. Moving away from the traditional line voltage connection per each appliance, this system has one centralized line voltage connection, and here you can see with these numbered connectors here, we've got 16 separate DC channels coming out, and those can be connected to the T-bar grid, which has essentially a distributed conductive bus both above the ceiling. You can see this connection here, and this connection here is powering this fixture. You can see how easy it is to disconnect the fixture and reposition it in the grid. So when we drop it back down, you can see the light power back up, and it's as easy as that to move the fixture. The T-bar also has recessed into the spline under, this would be below the ceiling if you wanted to power up a speaker or a security camera or a track light. You can snap this connector into the spline, make that twist lock, and you have your power connection. So once again, easy to move, it's safe, it's all class 2, low voltage. Another thing that's interesting about this system is the ability to police power density. When the system's installed, there's a 100-watt limit per channel, and so as you lay out the conductive T-bar pieces, you can actually assign wattage to a certain square footage in the space.
Great. And with this is just a converter. It converts it to the AC to DC so that it can all go out, as opposed to having each individual appliance that might be attached to it having to do the conversion on its own. Yeah,
correct. Most appliances in commercial spaces do make an AC to DC conversion. Lighting ballasts and drivers do that. Your computer does that. Speakers and cameras do that. And so the concept here, there's an efficiency gain to be made with essentially removing all of those at a micro scale and combining them at this one larger AC to DC conversion. This system can also be designed to take high voltage DC input, so it's really got a lot of applications for both commercial and industrial.
Right, so if you have a large DC input coming in, you can take that and then use it just to split out smaller DC power supplies wherever you want them.
Yep, that's correct.
What about data centers? What about, like you mentioned, industrial or other uses? Like, who might be interested in this?
Yeah, large data centers who desire basically the flexibility of this system and having a high quality power source essentially available to them wherever they're at in the room. This system provides that functionality. Also, large construction projects where you've got millions and millions of square feet, and you may have several tenant improvement changes during the course of construction. This provides you with a level of flexibility that you didn't have before. As far as redesign, you can essentially lay this system out and just leave it as such until they move in, and then you can put the appliances, the fixtures, wherever you want.
Yeah, so it's really configurable.
Yes.
How easy is it just to move things around if you decide, I need to move my office around?
Yeah, it's really easy to just pop out a light fixture and appliance. Again, anyone can do it because it's class 2 low voltage DC. You can take the appliance out of the grid.
And you're totally touching the T-bar here.
Yeah.
You don't want to touch that, right?
You don't want to touch it directly. This of course has a number of safety measures put into it to protect from shorts, basically. But I think you could find a way to get bit a little bit off of that. So you do want to be a little mindful. There's always a way. Yeah, you do want to be a little mindful, but for all intents and purposes, it's much safer than Class 1 wiring.
In terms of other stuff that you're working on around here, plasma light, can we talk about that a little bit? I think I've heard of this plasma light, and it sounds really cool.
Yeah, we can talk about the plasma lamp. We've got a plasma lamp over here in our integrating sphere.
Okay.
Plasma lamps are essentially next generation high intensity discharge lamps, where traditional HID lighting systems have electrodes. This system uses an RF driver to induce a current across the arc. The electrode is the primary mode of failure and lumen depreciation in traditional HID lamps, so the plasma light source doesn't experience any of those negative effects. There's a few companies that are developing this technology right now, and it's starting to emerge into the marketplace. There's lots of demonstrations, and there are a lot of customers that are interested in its potential for saving energy.
Yeah, why is it, in terms of being next generation high intensity discharge, why are people interested in looking at the plasma lamp as opposed to the lamps that are currently being used?
Plasma offers the potential for increased lamp life, so you have reduced maintenance costs. Also, the controllability of it, it may offer some improved dimming characteristics over the traditional lighting technologies. So if you're inside, you can imagine like a retail application or even a gymnasium. If you wanted to dim the lights nicely, that would be desirable. So you could still have all the benefits of the high lumen density that these high wattage lamps offer you. You have less fixtures on the ceiling, but you can also dim them.
That would be pretty amazing to be able to adjust the lighting to the way that you want it.
Yep.
Yeah. In terms of the brightness, how much discharge? What's the intensity discharge these lights are capable of putting out?
Yeah, right now we're seeing efficacies from these systems that are comparable to the kind of top of the line LED systems that are out right now. And there's still some performance gains to be made with this technology, so I think we're going to see it's just going to keep getting better and better.
Wow, so in terms of the output versus how much energy goes in, do you think comparable to LEDs in terms, or eventually beating them and better for certain applications?
Yeah, I think you're going to find that, I mean, here at the center we're very application specific, and every source has a home basically.
Yeah.
So I think in some instances this could make more sense than LED right now. I think in theory you're going to see LED, in the end probably beat out most everything, but that's in the future. So for energy savings right now, this has a lot of applications.
Cool. Very interesting. Is there anything else here that, in terms of where lighting is going and the technologies behind it, that you think is just really pushing the envelope?
Well, I think adaptive lighting controls is a huge area that needs to be expanded, and there's a lot of development work going on there right now. So looking at how we can design systems that will basically interpret an occupant's intent and then adjust the system accordingly. So I think compatibility of technologies is probably the #1 barrier to energy efficiency.
Small changes when it comes to lighting can actually make a very big difference. That's it for the California Lighting and Technology Center. I'm done green hunting for this week. I'm Dr. Kiki. Find me someplace else next time.
That's it for this episode of Green Tech Today. Subscribe at twit.tv/GTT and never miss a show. If you have a question or a comment, email us at greentechtoday@twit.tv. Or you can leave a voicemail at 415-GT-TODAY.